Okay. For some reason, my QuickTime recorder went completely south on me. Okay, for the next 7 questions that you're going to have, we're going to look at. I'm going to show you how we would do Aaron Judge's home run, and then you're going to look at Salvador Perez's home run that he hit. And I've got the website, so if you want to watch the home run that he hit back in October of 2015, which was a huge October for the Royals, as the year they won the World Series for the second time. Um, and but Salvador Perez was hit 21 home runs. That was a Royals record for a catcher. Um, anyway, so we're going to do the same thing that I'm asking you to do with Salvador Perez's home run, but we're going to do it with Aaron Judge's home run. Let's watch it one more time.
To Judge.
Bang.
A high drive to deep center. That ball is high. It is far. It is gone.
I couldn't
Oh,
even
what
see
a
the ball on my
Judgian
computer screen. I
blast
don't know about you
to
all.
Monument Park in dead center field. All rise. Here comes the Judge. Aaron Judge homers to dead center.
It
And
is
way
kind of fun
over the
because that's the
Monument
Yankees
Park wall.
announcer.
And the Yankees trail 4-1.
And then they came back and won that game, actually, 8-4. All right. Anyway, so that was Judge's home run. Now let's go back though, and here's the data. We'll look at the data here. He hit it against Will Harris in Yankee Stadium, and that's not the one I'm after. It was this one. Sorry. It was against Lance McCullers in the 7th inning, hit in Yankee Stadium, and it went 452 feet. Okay? So we're going to have to convert that to meters, and it went 108.7 miles per hour at an elevation angle of 27.2 degrees. Okay? So walk with me here. All right, here we go. Let's write down the data that we know. The angle was 27.2 degrees. The distance that it went, D, was equal to, what is the distance? 452 feet. And it was hit, how fast was it hit again? 108.7 miles per hour. So its velocity off the bat was 108.7 miles per hour. All right, so we've got to convert this to meters. We've got to convert this to meters per second. All right, so I'm going to go to your Salvi problem that you have, but I'm going to use Aaron Judge's data, all right, so that you can see how it's done. So you can kind of get a blueprint for it and go, okay, I think I can do this. All right, so let's look at this. All right, so there's stuff on the Magnus force and a few other things, and then there it is. Now, Salvador Perez broke, so he hit it at 107 miles per hour at an angle of 25 degrees. We're looking at 27.2 degrees. And okay, calculate using the cosine function the horizontal velocity of the ball leaving the bat. First, you have to convert the 107 miles per hour to meters per second. All right, so what does that look like? So what are you going to do? So with Aaron Judge, we'd go, 108.7 times 0.447, which is our conversion factor to meters per second, and we get a nice 108.7 times 0.447, and that equals 48.6 meters per second. Now, that's this one. Remember, we've got to look at the V naught X and the V naught Y of the ball. We're just going to look at V naught X. All we're worried about is just finding the range. We are after the range, which is going to equal that initial velocity in the X direction times the time the ball was in the air. Okay? And we're going to compute that. All right? We're going to have to we're going to have to look at the Y part too, which we know how to do now. In fact, right now, let's we can find the y part, but I want to follow along with what it's doing here. Using the sine function, find the vertical velocity. Oh, okay. So for our problem, for Aaron Judge's home run, we go, okay, well, we're going to use the sine function. Oh, I haven't used the cosine function yet of the 27.2 degrees here. So V naught x is equal to V naught, this is V naught, okay, and this is V naught in the 48 meters, times the cosine of 27.2 degrees. I forget, these are kind of tricky. 48.6 times the cosine of 27 is equal to 43.3 meters per second. All right, we're cooking with gas. And now we've got to find V naught y, which would equal 48.6 meters per second times the sine of 27.2 degrees. And that equals 22.2 meters per second. All right, let's see what else we got to find here. And then I'll probably stop and we'll go on to the next. Okay, what is the final vertical velocity? Okay, what does it come up? And it comes down. Okay, so the final vertical velocity is equal for my question 10, my final vertical velocity is, this is V final y is equal to negative 22.2 meters per second. So we found that out. All right, so this would be the answer to question 10. This is the answer to question 9. Back here is the answer to question 8. And let's stop there because we've got 4 more to do, and I don't want to have this be 30 minutes long. Well, it won't